objective number 3. Is the overall model useful? Now, again, to save time, I'll answer my own questions. 8.0 is going to be the model. Model is not useful. We always express the 8.0 in the negative. Model not useful, meaning that all the x's drop out of the equation. None of the x's are valuable. And model is useful would be the H1. And we can say it 3 different ways. The first way we can say it is, like I said, remember we had it last time, beta 1 equals 0. But now we have a lot of betas, beta 2, beta 3, beta 4. In this case, let's take the example of 2 variables. Beta 1 equals beta 2 equals 0. I just want to point out to you, if on the test or the homework there turns out to be 3 x's, then you got to do beta 3. For each x, there got to be a corresponding beta. So beta 1 for x1, beta 2 for x2. What's the H1 going to be? Well, don't make the mistake that, don't write this down even, beta 2. That's 4. Because what's the opposite that they're all equal to 0? That at least one of them is not 0. This would be not true. So what the way to say down the proper way of saying the H1 is that either beta 1 is not equal 0, meaning that x1 really does help make a prediction, or x2 makes a prediction, or x3, or etc. You can simplify your life by simply putting down for the H1, 8.0 not true. But when 8.0 not true means that either B1 is not equal to 0, or B2 is not equal to 0, or both. Maybe they're both useful. But it turns out there's an easier way to express the 8.0 and the H1, and that's using something called, which we're up to right now, the coefficient to multiple determination. Now, anybody recall the coefficient of determination? Leave a space there, please. I'm going to put in the word determination. Anybody recall the symbol for the terminology? Yes, Marco. So very good. So the R squared of chapter 13 was called the coefficient to multiple of determination, and it represented what percentage of the y is being explained by the x. Now that we have chapter 14 of many variables, it's going to be called the coefficient of multiple determination, and it means the same thing, multiple determination. And a symbol is going to be the capital R squared. That's capital R squared. By the way, if you never learned chapter 13, but you only know chapter 14, could you do can you do everything in chapter 13 by using chapter 14? And the answer, of course, is yes, because all you have is simply 1x. Beta 1 equals, otherwise chapter 14 boils down to chapter 13 if you have just 1x. Now, if the x and y are totally unrelated, what would you expect the R squared to be? If all the x's are totally unrelated to the y, what would you expect the R squared to be? And the answer is 0. And if the x's are related to the y, either one of them or 2 of them or both of them or all 3 of them, if there are 3 of them, what would you expect the R squared to be? No, if it's, it depends on the sample size. The answer is bigger than 0, or not 0. So the 2 possibilities here are R squared equals 0 means that the x's are not related to the y, and the R squared bigger than 0 would be the alternative hypothesis. It can't be not equal because you can't have a negative R squared. Okay, so now we have one of 3 ways of writing out the hypotheses. What's going to be step number 2? Doing a calculation. And what's the calculation? In this case, it's going to be called an F calculation. And it's going to be the following formula, which again is different in the book. The book has a whole different approach to using sums of squares, etc. But since the R squared is available to you on the printout, it's R squared divided by K, and we have to talk about what K stands for, and this whole thing divided by 1 minus R squared, which is the amount that's unexplained, divided by N minus K minus 1. So the only 2 variables that we haven't seen yet are the K. What's the K stand for? Anybody want to take a lucky guess? What does K stand for? Yes. The number of independent variables. In this case, what would be K in this example? This is probably one of the biggest mistakes on the test. What would K be in this particular example that's on the board that we've been talking about? Yes. 2. Now, a lot of people think K stands for the number of variables. Now, how many variables do we have in the problem? 3. 2 x's and 1 y. There's always 1 y. So K stands for the number of x's. In this case, K will be 2, and that's an important thing to write down and remember. What is K stands for the number of x's or independent variables. And n, of course, stands for how many lines of data you have. You know, not the number of data, not the number of dot points, but I mean the number, if you graph this in three-dimensional space, will be points, but the number of lines of data will be the n. And after all is said and done, you get this number. But does the computer also print out the F number on the page of the print of the multiple regression? Yeah, you show that to the ANOVA table. That's where the F comes in. So there is an F printed out for you. On the test, for some reason, which I don't really, maybe I can't justify this year because we're doing a little differently, but anyway, just in case I do it again the same way, I white out the F. This is one of the only equations I expect you to calculate for chapter 14. You figure out the R squared over here, 0.52. You plug in a 0.52 there. So 0.52 divided by how much? 2, which is about 0.26. And how much is 1 minus 52? 0.48 divided by, what's the n in this example? Well, we had the data in the previous slide, but I think there's 15. It said number of observations are 15. There are 15 observations in this previous, the camera can't see it, but there are 15. So it'll be 15 minus 2. By the point is, I'm not going to do this right now, but you plug it into this equation, and you're going to get the same exact number as the F. It should come out to 6.53 in that case. All right, now, what's step number 3 going to be? Always a diagram, which is, again, why it's amazing people, whatever. All right, so the diagram in this case will be an F diagram, not surprising, which starts out with a 0, the same as chapter 11, starts out with a 0. The alpha is on the right side, the reject region is on the right side also. The do not reject is here. You only have a one-tailed test. You never chop the alpha in half, which makes it easy.
Wait, so with F, you never chop it in half?
Yep, you never chop the alpha in half for the F. Well, it turns out like there's no rule. There's always a possibility, but for our class, you're never going to chop it in half. And finally, you got to be taught the degree of freedom, right? You know, in order to go to the F test, you got to go. You have to, in fact, have 2 different degrees of freedom: how much across the top of the page you go, and how much down the side of the page you go. So let's turn. If you want to do it right now, let's take an example where we have alpha 5%. And the degree of freedom, which I should tell you, is going to be, this is the degree of freedom across, and this number over here is the degree of freedom down. So you go 2 across, and you go down 15 minus 2 minus 1, which is equal to 12. 12 down, and what do you see there on the 0.05 F table? For those of you who have a table and want to look it up just to make sure you're doing the right thing, when you go to the F table, 0.05 page of the F table, 2 across and 12 down, K is 2. K is the number of x's. Hold on a second. No, you go K across. You go K across, and the n minus K minus 1 down. Anybody have it up? Anybody have it yet? You go K across, which is 2. K across, which is 2, and n minus K minus. It's built into the formula, so you don't have to write it down separately. What do you get? Say again. 3.89, Sarah says. 3.89. Anybody confirm that? Okay, so 3.89. And of course, in our case, since the F number came out to 6.5, I'll put it down for the people who don't have that. What do they say? 6.53. And 6.53 is to the right of that. The answer, first of all, is reject date 0. And of course, like always, for another set of points to interpret that, so the model is useful. If the question might say, is there evidence the model is useful? Yes, the model is useful. And we'll take, now, for those of you who are going to be doing this on a spinner assignment, which you will be doing eventually, and that's the last spinner assignment of the whole term, how else would you answer this question besides doing it by hand? How else can you do it using the printout that's on the board? The answer, thank you, is the p-value. Now, that doesn't say the word p-value, but the significance of f is, if you might want to write this down, this is where the p-value is found. This 0, 1, 2 is a p-value. So the p-value is the significance, which in this case turned out to be 0.012. And since that is lower than the alpha of 5%, the implication is, again, to reject a 0. If the p-value is lower than the alpha, you reject a 0. So that's the easiest way to do it without having to go through all this other rigmarole. It's not called p-value here. It's called significance of the f. But this it means the same thing as the p-value. This is the printout that you're going to be getting. This whole printout. Maybe I might erase this number here. But you can get that F number by doing this calculation.